Hello students, welcome to Sri Jayendra Running Zone classes. I am your friend and mentor for coming classes with respect to business mathematics and statistics. This is lecture number 33, chapter number 8, basic concepts of differential and integral calculus. Now start with introduction to differential and integral calculus excluding trigonometric functions. A. Differential calculus. Differentiation is one of the most important and fundamental operation in calculus. Its theory primarily depends on the idea of limit and continuity of function. To express the rate of change in any function, we introduce concept of derivative, which involves a very small change in the independent variable with a reference to a very small change in independent variable. Thus, differentiation is the process of finding the derivative of a continuous function. It is defined as the limiting value of the ratio of the change increment in the function corresponding to small change increment in the independent variable argument as the latter tends to 0. Derivative or differential coefficient. Y is equal to f of x. Be a function if h or delta x be the small increment in x and the corresponding increment in y, or f of x be delta y is equal to f of x plus h minus f of x, then the derivative of f of x is defined as limit h tends to 0 f of x plus h minus f of x by h. Instead of h, put delta x or del x. Limit delta x tends to 0 f of x plus delta x minus f of x upon delta x. This is denoted as f dash x or dy by dx or d by dx fx. The derivative of f of x is also known as differential coefficient of f of x with respect to x. This process of differentiation is called the first principle or definitions. Note, in the light of the above discussion, a function f of x is said to differentiable at x is equal to c. Limit h tends to c f of x minus f of c upon x minus c exists, which is called the differential coefficient of f of x at x is equal to c and is denoted by f dash c or dy by dx at x is equal to c. We will now study this with an example. Consider the function f of x is equal to x square. By definition, d by dx f of x is equal to limit delta x tends to 0 f of x plus delta x minus f of x upon delta x is equal to f of limit delta x tends to 0 x plus delta x square minus x square upon delta x. So it is x square plus 2x delta x plus delta x whole square minus x square plus x square minus x square cancel. Limit delta x tends to 0 2x plus delta x is equal to 2x plus 0 is equal to 2x. Thus, derivative of f of x exists for all values of x and equals 2x at any point x. Examples of differentiation from the first principle. F of x is equal to c, c being a constant. C is constant, we may write f of x plus h is equal to c. So, f of x plus h minus f of x is equal to 0. F dash x is equal to limit h tends to 0 f of x plus h minus f of x upon h. So, here put the x plus h minus f of x is equal to 0. 0 by h is equal to 0. So, dc by dx is equal to 0. Let f of x is equal to x raised to n f of x plus h, you can write x plus h raised to n. Take x plus h is equal to t, or h is equal to t minus x. H tends to 0, t tends to x. So f dash x is equal to limit h tends to 0, f of x plus h minus f of x upon h. Limit h tends to 0, x plus h raised to n minus x raised to n upon h. X plus h is equal to t. So put the value t raised to n minus x raised to n by t minus x. The formula is n into x raised to n minus 1. So d by dx of x raised to n is equal to n into x raised to n minus 1. F of x is equal to e raised to x, and so f of x plus h is equal to e raised to x plus h. Here e raised to x plus h minus e raised to x upon h. Okay, you can write e raised to x into e raised to h minus e raised to x upon h. So e raised to x common, so it becomes e raised to h minus 1 upon h. Okay, so e raised to x common, limit here, limit is h tends to 0, so e raised to h minus 1 upon h, e raised to x into 1. So d by dx of e raised to x is equal to e raised to x. F of x is equal to a raised to x, so it is a raised to x plus h. So you can write a raised to x plus h minus a raised to x upon h, a raised to x into a raised to h minus a raised to x upon h. A raised to x common, a raised to h minus 1 upon h. So a raised to x common, limit h tends to 0, a raised to h minus 1 upon h. So a raised to x log a. So d by dx a raised to x is equal to a raised to x log a. F of x is equal to root x. X plus h is equal to under root x plus h. So under root x plus h minus under root x by h. Multiply with under root x plus h plus under root x, under root x plus h plus under root x. So this is the formula of x minus y, x plus y. So you will get x square minus y square. For these you will get root x plus h square minus under root x square. So x plus h root cancel, minus x. So minus x plus x cancel, h upon h, h cancel. So 1 upon under root x plus h plus under root x is equal to 1 upon h, put h is equal to 0. So you will get under root x plus under root x is equal to 1 upon 2 under root x. So d by dx is equal to, d by dx of root x is equal to 1 upon 2 under root x. F of x is equal to log x, and then f of x plus h is equal to log x plus h. So log x plus h minus log x upon h. Then here minus sign, so you can write log x plus h upon x by h. 1 upon h log x plus h upon x is equal to x by x plus h by x. X cancel, so it is 1 plus h by x. So h by x is equal to t, h is equal to tx, as h tends to 0, t tends to 0. F dash x is equal to limit t tends to 0, 1 upon tx log 1 plus t is equal to 1 by x. Limit t tends to 0, 1 by t log 1 plus t is equal to 1 upon x into 1 is equal to 1 by x. Since limit t tends to 0, log 1 plus t upon t is equal to 1. So d by dx log x is equal to 1 upon x. Some standard results or formulas. D by dx of xn x raised to n is equal to n into x raised to n minus 1. Second one is d by dx e raised to x is equal to e raised to x. Third one is d by dx a raised to x is equal to a raised to x log a. D by dx of constant is equal to 0. D by dx e raised to ax is equal to a into e raised to ax. D by dx log x is equal to 1 by x. D by dx c f of x is equal to c f dash x, c being constant. In brief, we may write below the above functions at their derivatives. Function f of x, derivative of the function f dash x. X raised to n, n into x raised to n minus 1. E raised to ax, a into e raised to ax. Log x, 1 by x. A raised to x, a raised to x log a. C or any constant. Derivative of any constant is equal to 0. So you have to remember all the formulas. Okay. Here, basic law for differentiation. First, h of x is equal to c into f of x, where c is any real constant, scalar multiple of a function. Derivative of the function d by dx h of x is equal to c constant common d by dx f of x. So you have to take the differentiation of f of x. H of x is equal to f of x plus or minus g of x. D by dx h of x is equal to d by dx f of x plus or minus d by dx of g of x. H of x is equal to f of x into g of x. D by dx h of x is equal to f of x into d by dx of g of x plus g of x d by dx of f of x. Fourth one, h of x is equal to f of x by g of x. D by dx h of x is equal to g of x constant d by dx f of x minus f of x constant d by dx g of x upon g of x whole square. Okay. H of x is equal to f into g of x. D by dx h of x is equal to d by dz f of z dz by dx, where z is equal to g of x. It should be noted here, even though in 2, 3, 4 and 5 we have considered two functions f and g, it can be extended to more than two functions by taking 2 by 2. So remember the basic law for differentiation and use it. Okay, and solve the example or solve the questions. Okay, so remember it. Example, differentiate each of the following functions with respect to x. First one is 3x square plus 5x minus 2. Solution, let y is equal to f of x, 3x square plus 5x minus 2. So here dy by dx is equal to d by dx of 3x square plus 5x minus 2. So here 3 common, d by dx of x square plus 5 common, dx by dx minus constant, so 0. So here 3 x square n into, here you have to use the formula For this, n into x raised to n minus 1, x raised to n, d by dx of x raised to n. So 3 into 2, x raised to 2 minus 1, so x, plus 5 dx by dx 1, okay. 3 into 2, 6x plus 5, okay. Let b h of x is equal to a raised to x plus x raised to a plus a raised to a. Take the differentiation both sides. D by dx a raised to x plus x raised to a plus a raised to a. D by dx a raised to x plus d by dx x raised to a plus d by dx a raised to a. A raised to a is a constant. Here d by dx of a raised to x is equal to a raised to x log a. Remember the formula, okay. Here x raised to a, this is the form in the form of d by dx x raised to n, n into x raised to n minus 1. So a into x raised to a minus 1. Constant 0. Differentiation of constant is 0. So a raised to x log a plus a into x raised to a minus 1. Let f of x is equal to 1 by 3 x cube minus 5x square plus 6x minus 2 log x plus 3. Take the differentiation both sides. 1 by 3 x cube, so 3x square, x raised to n formula, 5x square x raised to n formula, 6x log x, so d by dx of log x formula, okay. So here you can write 1 by 3 into x square minus 5x square 2x plus 6x dx by dx 1, so 6 into 1 minus 2 log x 1 by x plus 0. So 3 cancel, x square minus 5 2s are 10x plus 6 minus 2 upon x. D y is equal to e raised to x log x. dy by dx e raised to x, product rule, e raised to x as it is d by dx log x plus log x as it is d by dx e raised to x, d by dx of log x is 1 by x, d by dx of e raised to x is e raised to x. So put this e raised to x by x plus e raised to x log x. So e raised to x by x one plus x log x. So dy by dx is equal to e raised to x by x 1 plus x log x. So here they are using e raised to x plus e raised to x log x, okay. Take LCM x, e raised to x into x log x upon x. Now common e raised to x. So after this step and last e raised to x by x in the bracket 1 plus x log x. Y is equal to 2 raised to x into x raised to 5. So dy by dx is equal to x raised to 5, again using product rule, d by dx 2 raised to x plus 2 raised to x d by dx x raised to 5. The simple product rule is y is equal to u into v, dy by dx v as it is d by dx du by dx, okay, plus u as it is dv by dx. So x raised to 5, 2 raised to x in the form of d by dx of a raised to x is equal to a raised to x log a, and x raised to 5. So it is d by dx x raised to n, n into x raised to n minus 1. So x raised to 5 d by dx 2 raised to x plus 2 raised to x d by dx x raised to 5. X raised to 5 into 2 raised to x log 2 plus 5 into 2 raised to x x raised to 4. Now y is equal to x square upon e raised to x. This is the quotient rule. Here e raised to x as it is, d by dx of x square minus x square d by dx of e raised to x upon e raised to x whole square. So e raised to x as it is, x square 2x, x square e raised to x, e raised to x. D by dx of e raised to x is e raised to x. So put into this x square into e raised to x upon e raised to x whole square. Now e raised to x common. So 2x minus x square e raised to x square. 1 e raised to x cancel. So it is x common 2 minus x upon e raised to x. Y is equal to e raised to x by log x. So again quotient rule, log x d by dx e raised to x minus e raised to x d by dx log x upon log x whole square. So log x as it is, e raised to x, differentiation of e raised to x is e raised to x. And differentiation of log x is equal to 1 upon x. So e raised to x log x minus e raised to x by x upon log x whole square. E raised to x, x log x minus e raised to x upon x log x whole square. So dy by dx e raised to x, x log x minus 1 upon x log x whole square. Let h of x is equal to 2 raised to x into log x. The given function h of x is appearing here as product of two functions, 2 raised to x and log x. So you can write f of x is equal to 2 raised to x, g of x is equal to log x. So d by dx of h of x. So d by dx of 2 raised to x log x. 2 raised to x common, d by dx log x plus log x common, d by dx of 2 raised to x. Here you have to use a raised to x formula. D by dx of log x is equal to 1 by x, and d by dx of a raised to x is equal to a raised to x log a. So 2 raised to x into 1 by x plus log x into 2 raised to x log 2. 2 raised to x by x plus 2 raised to x log 2 log x. Let h of x is equal to 2x by 3x cube plus 7. Given function appears as the quotient of two functions. F of x is equal to 2x. G of x is equal to 3x cube plus 7. D by dx h of x is equal to 3x cube plus 7 d by dx 2x minus 2x d by dx 3x cube plus 7 upon 3x cube plus 7 whole square is equal to 3x cube plus 7 into 2x. So it is 2 minus 2x 3x cube. So it is, here you have to use d by dx of x raised to n formula, n into x raised to n minus 1. D by dx of x cube is equal to 3 into x square. So it is 3 into 3x square. So 9x square, 7 is constant, so 0 upon 3x cube plus 7 whole square. 2, 3x cube plus 7 minus 9x cube upon 3x cube plus 7 whole square is equal to, so here 3x cube plus 7 minus 9x cube upon 3x cube plus 7 square. 9, 3 minus 3. So 7 minus 6x cube upon 3x cube plus 7 whole square, or 2 constant. Okay. Derivative of a function of function. If y is equal to f or f of h of x, dy by dx is equal to dy by du into du by dx. So f dash u into h dash x, where u is equal to h of x. Example: differentiate log 1 plus x square with respect to x. So here y is equal to log 1 plus x square is equal to, here consider t is equal to 1 plus x square. So you can write log t. So dy by dx is equal to dy by dt with respect to t, or dt by dx. So dy by dt, so it is log t, so 1 upon t into dt by dx. Y is equal to log t. So dy by dt is equal to d by dt of log t, 1 upon t, and t dt by dx is equal to constant 1, 0, x square. So it is 2x, 0 plus 2x, so 2x by t. T, value of t is 1 plus x square, so 2x upon 1 plus x square. This is an example of derivative of function of a function, and the rule is called the chain rule. Implicit functions. A function in the form f of xy is equal to 0. For example, x square y square plus 3xy plus y is equal to 0, where y cannot be directly defined as a function of x, is called an implicit function of x. In case of implicit functions, if y be a differentiable function of x, no attempt is required to express y as an explicit function of x for finding out dy by dx. In such case, differentiation of both sides with respect of x and substitution of dy by dx is equal to y1 gives the result. Thereafter, y1 may be obtained by solving the resulting equation. Find dy by dx for x square y square plus 3xy plus y is equal to 0. Now, differentiating with respect to x. Okay. So first is x square y square. Divide this equation into 3 parts. First you have to differentiate the x square y square, then 3xy, and then y. Okay. So for x square y square you have to apply product rule. Okay. So x square as it is d by dx of y square plus y square as it is d by dx of x square. Okay. For the 3xy, 3 constant. So here x as it is dy by dx plus y as it is dx by dx. For the y, it is dy by dx. Okay. So 3x dy by dx y plus 3y dx by dx plus dy by dx is equal to 0. For the 1, for the 2, and for the 3. So here x square as it is y square, so 2y x square dy by dx. Because here you are differentiating with respect to x, so you have to write dy by dx. 2xy square x square, so 2xy square plus 3x dy by dx plus 3y dx by dx any 1 plus dy by dx. Here 2y x square plus 3x plus 1 dy by dx plus 2xy square plus 3y is equal to 0. So 2xy square plus 3y, take another side, it becomes minus. So dy by dx is equal to minus 2xy square plus 3y upon 2x square y plus 3x plus 1. This is the procedure for differentiation of implicit function. Parametric equation. When both the variables x and y are expressed in terms of a parameter, a third variable, the involved equations are called parametric equations. For the parametric equation x is equal to f of t, y is equal to h of t, the differential coefficient dy by dx. So dy by dx is equal to dy by dt by dx by dt. So it can be write dy by dt into dt by dx. Find dy by dx if x is equal to a t cube and y is equal to a by t cube. X is equal to a into t cube. So you can write dx by dt. A d by dt of t cube is equal to a 3t square. So 3a t square. Dy by dt is equal to minus 3 upon t raised to 4. Here a into t raised to minus 3. Okay. So a constant as it is, minus 3 and minus 3 minus 1, t raised to minus 4. So divide by t raised to 4. Now dy by dx, dy by dt into dt by dx is equal to dy by dt is minus 3 upon t raised to 4 into dt by dx 1 upon 3 a t square. 3 cancel, a cancel, 1 upon t raised to 6 minus 1 upon t raised to 6. This is the procedure for differentiation of parametric functions. Logarithmic differentiation. The process of finding out derivative by taking logarithm in the first instance is called logarithmic differentiation. The procedure is convenient to adopt when the function to be differentiated involves a function in its power or when the function is the product of number of functions. Example, differentiate x raised to x with respect to x. Here y is equal to x raised to x. Taking logarithm log y is equal to x log x. Differentiating with respect to x. Log y, so 1 upon y dy by dx. Apply product rule. So d by dx of log y, d by dx of x into log x. So it is 1 upon y dy by dx x constant d log x by dx plus log x constant dx by dx 1 upon x plus log x. X cancel. So 1 upon y dy by dx is equal to 1 plus log x. So dy by dx is equal to y into 1 plus log x. Put the value of y, x raised to x, 1 plus log x. This procedure is called logarithmic differentiation. Some more examples. Y is equal to under root 1 minus x upon 1 plus x. So that 1 minus x squared dy by dx plus y is equal to 0. Taking logarithm, we may write log y is equal to 1 by 2 log 1 minus x minus log 1 plus x. Also you can write as y is equal to 1 minus x 1 plus x raised to 1 half. Okay. So take log both sides, 1 by 2 log 1 minus x, differentiation sign, subtraction sign, minus log 1 plus x. So differentiating throughout, we have 1 by y dy by dx is equal to 1 by 2 d by dx of log 1 minus x minus log 1 plus x. So 1 by 2, 1 minus x, so 1 upon x, so 1 upon 1 minus x. Take the again differentiation. Now 1 by 2, 1 upon 1 minus x. Take the differentiation of 1 minus x, because this is not the original form. Minus log 1 plus x minus 1 upon 1 plus x d by dx of 1 plus x. So 1 by 2, 1 upon 1 minus x, 1 0 minus x minus 1 minus 1 upon 1 plus x, 1 0 plus x into 1. So it is minus 1 upon 1 minus x minus 1 upon 1 plus x is equal to, after solving this we will get minus 1 upon 1 minus x square. So 1 minus x square dy by dx is equal to minus y. Take left side, so it becomes 1 minus x square dy by dx plus y is equal to 0. Differentiate the following with respect to x. Log x plus under root x square plus s square. So log x plus under root x square plus x square dy by dx is equal to, so d by dx of log x is equal to 1 upon x. So you can write 1 upon x plus under root x square plus s square, and take the again differentiation of this. So you can write dy by dx is equal to 1 upon x plus under root x square plus s square into d by dx of x plus under root x square plus s square. So it is 1 plus under root x, differentiation of x is 1. Root x is 1 upon 2 root x. So 1 upon 2 under root x square plus s square. Again take differentiation of this. So it becomes 2x. So 2 cancel. 1 upon x plus under root x square plus s square plus 1 upon x plus under root x square plus s square into x square under root of x square plus s square, in the numerator x. Okay. So x plus under root x square plus s square upon x plus under root x square plus s square into under root x square plus s square. Here this cancel. So 1 upon under root x square plus s a square. B. Y is equal to log under root x minus a plus under root x minus b. So dy by dx log x 1 upon x. So put the under root x minus a plus under root x minus b. Again take differentiation, because this is not the original form. So differentiation of under root x minus a plus under root x minus b. So d by dx of root x is equal to 1 upon 2 under root x. Here root x minus a, so 1 upon 2 under root x minus a d by dx of x minus a. Here you have to write 1 upon 2 under root x minus a d by dx of x minus a. Here x d by dx of x is 1 and a constant, so 0. For this 1 upon 2 under root x minus b, so d by dx of x minus b. Same way, d by dx by dx 1 and b 0. So you will get the 1 upon under root x minus a plus under root x minus b 1 upon 2 under root x minus a plus 1 upon 2 under root x minus b is equal to under root x minus b plus under root x minus a upon under root x minus a plus under root x minus b 2 under root x minus a under root x minus b. So this bracket cancel. So you will get 1 upon 2 under root x minus a into under root x minus b. If x raised to m y raised to n is equal to x plus y raised to m plus n, prove that dy by dx is equal to y by x. Take log both the sides. So log x raised to m y raised to n is equal to m plus n log x plus y. M log x plus n log y is equal to m plus n log x plus y. So d by dx of log x is equal to 1 upon x, so m by x plus log y 1 upon y n upon y dy by dx. M plus n log x plus y 1 upon x plus y d by dx of, here it is the d by dx of x plus y. So x 1 plus dy by dx. So n of y minus m plus n upon x plus y dy by dx is equal to m plus n upon x plus y minus m by x. So take the LCM of x plus y and y, nx plus ny minus my minus ny plus ny minus ny cancel. Dy by dx is equal to, here mx plus nx minus mx minus my. So here mx plus mx minus mx cancel is equal to nx minus my upon x. X plus y both side cancel. So nx minus my upon y dy by dx is equal to nx minus my by x, or dy by dx nx minus my cancel. So dy by dx is equal to y upon x, proved. Next one, if x raised to y is equal to e raised to x minus y, prove that dy by dx is equal to log x upon 1 plus log x whole square. X raised to y is equal to e raised to x minus y. Take log. So y log x is equal to x minus y log e. So y log x is equal to x minus y. Log e 1. Okay. Here log. So only x minus y. Differentiating with respect to x, we get y upon x plus log x dy by dx is equal to 1 minus dy by dx. So 1 plus log x dy by dx is equal to 1 minus y upon x. So dy by dx is equal to, here you can write x minus y upon x. So x minus y upon x into 1 plus log x. Substituting x minus y is equal to log x from equation A. Is equal to y log x. So y log x, x into 1 plus log x. So from a, y into 1 plus log x is equal to x. So y by x is equal to 1 upon 1 plus log x. Dy by dx is equal to y log x, x 1 plus log x. Y by x is equal to 1 upon 1 plus log x. So log x 1 plus log x into 1 plus log x. So log x upon 1 plus log x square. Okay. So this lecture is over here. Okay. Next time we will study about basic idea about higher order differentiation. Okay. See you soon. Bye bye.